Let's proceed to our problem number 2. Express the Boolean function f equals xy plus x prime z as a product of max terms. So, just like in problem number 1, we need to contain all the variables by x, y, z. So, here it lacks z variables, so we just need to add or multiply z plus z prime. Then here it lacks y variables, so we need to do the same way. We need to multiply y variable, y plus y prime. After that, we just distribute it or multiply one by one. So we have now xy z plus xy z prime plus xy zy plus x prime zy prime. Or we just need to arrange it so that it can easily determine. So we just simply invert this function so that we can have our final answer or the product of max terms. So we have now f prime equals x prime plus y prime plus z prime multiplied to x prime plus y prime plus z multiplied to x plus y prime plus z prime multiplied to x plus y plus z prime. So this is now the product of max term of the Boolean function f equals xy plus x prime z. So good morning, sir. This is now my final exam. For the problem number 1, express the Boolean function f equals a plus b prime c as a sum of minterms. So, if we are given a function f equals a plus b prime c, what we are going to do is to express this Boolean function as a sum of minterms. So, first, we need to do is contain this function of all the variables by ABC. So A is lack of B and C, so we must multiply B plus B prime and C plus C prime. In this one, it is lacked in A variable, so let's multiply it by A plus A prime. Then after that, we need to distribute or multiply one by one. So here it comes, AB plus AB prime, then bring down this one plus multiply this by this, so we will have A B prime C plus A prime B prime C. Then again multiply this in this one, so we have now ABC plus ABC prime plus AB prime C plus AB prime C prime plus AB prime C plus A prime B prime C. Now, as we can see here, AB prime C appears twice, here and here. And according to theorem 1, x plus x equals x. So it is possible that we will remove the other one. So we will now have our function or final answer. F is equal to ABC plus ABC prime plus AB prime C plus AB prime C prime plus A prime B prime C. Now, this is the sum of minterms. For our third problem, NAND and NOR gates are called universal gates. Show by drawing that AND, OR, and NOT can be implemented using NAND and NOR gates only. So this is our NOT gate and OR. In NOT, implementing an inverter using only NAND gates, all of the NAND inputs pins connect to the input signal A gives an output A prime or A naught. In NOR gates, implementing an inverter using NOR gates, all input pins connect to the input signal A also gives an output A prime. Next, in AND gate, implementing AND gate using NAND gate can be replaced by NAND gate, and the NAND gate with its output complemented by a NAND gate inverter. So if we have an input AB, the output is A B or A times B. In AND implementing using only NOR gates, this one, NOR gates, and AND gate can be replaced by NOR gates with all its input complemented by NOR gates. So this is the gates that we use. In OR gate, implementing using only NAND gate, an OR gate can be replaced by NAND gates. So the OR gates replaced by NAND gates with all of its input complemented by NAND gates inverter. Implementing OR using only NOR gates, an OR gate can be replaced by NOR gate. The OR gate is replaced by a NOR gate with its output complemented by a NOR gate inverter. So this is the drawing that AND, OR, and NOT can be implemented using NAND and NOR gates only. This is the NAND gates and this is the NOR gates. For problem number 4, create a simplified SOP expression for the following output. We are given a function of 0 to 31, 0, 1, 2, 3, 6, 7, 8, 9, 10, 12, 14, 16, 18, 20, 22, 23, 24, 29, 30, 31. Solve using K-map or Karnaugh map. Create the circuit diagram. Check your simplified expression using the truth table. So here I've already made a Karnaugh map or K map for the outputs. So we all know that the cells in Karnaugh map ordered in gray code and reflected by binary code, and each cell position represents one combination of input condition, while each cell value represents the corresponding output value. So as per given output, you can simply place the outputs to the corresponding position. So the output 0 is placed on the upper left of the K map. So here it is, and 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So it is our Karnaugh map. As you can see, there is a pattern for it. So we just simply mark the functions that is 1 or high. So we have our function 0. So 0 is 1, 1, 1, 2, 1, 3, 1. So 4 means 0 because it is not part of a function, and also 5, 0, 6, 1, 7, 1, 8, 1, 9, 1, 10, 1, 11, 0, then 12, 1, 14, 1, 13 and 15, 0, 16, 1, 17, 0, 18, 1, 19, 0, 20, 1, 21, 0, 22, 1, 23, 1, 24, 1, 25, 26, 27, 0, and 28, also 0, 29, 1, 30, 1, and 31, 1. The next thing that we'll do is to make rectangular groups which contains total terms in power of like 2, 4, and 8 exact for 1. So here it is, here, 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 then the other side, here, 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 and here. So from the groups that we made, we will obtain an SOP function of f is equal to a b c e plus a prime c prime d prime plus c prime d prime e prime plus a prime b prime d plus a prime b e prime plus a c d plus a b prime e prime. So this is the circuit diagram of problem number 4 with the function f equals a b c e plus a prime c prime d prime plus c prime d prime e prime plus a prime b prime d plus a prime b e prime plus a c d plus a b prime e prime. And for the truth table of this simplified expression, here it is. So if the input is 0, the output will be 1 or high. Then 1, if output is 1, it will be 1 also. If 2, it will be 1. 3 will be 1. And 4, it will be 0 or low. Then 5, and so on until 31. And lastly, for problem number 5, create the truth table for the hexadecimal to 7 segment that will display hexadecimal number from 0 to F for every combination of 4-bit inputs. So, this is now our answer. We have here the digital decoder IC with 7 in segments, which A, B, C, D, E, F, G. And we have here our inputs in truth table, hex value, and the 7 segments. Yes. And that would be all. Thank you.